The following presentation provides an overview of crash data in the public road corridor, and then a stop sign compliance study that was completed in February and March of 2018. The first slide here shows 6-year crash data from year 2012 to 2017. The information that you see on this chart was provided by City of Lafayette police reports. So these are reports that were filed with the Lafayette Police Department when a crash occurred in the public road corridor from South Boulder Road and Baseline. The y-axis, the tall axis, is the number of crashes reported each year, and then each bar on the horizontal axis represents a year. So you see in 2012, the bar is between 32 and 43 crashes, and then you can see 2013, 14, 15, 16, and 17. This presentation provides an overview of crash data in the public road corridor, and then the results of a stop sign compliance study that was conducted in February and March of 2018. The first slide here shows 6 years worth of crash data in the public road corridor from Baseline to the north to South Boulder to the south end. So in that stretch of public road from years 2012 to 2017, you can see the annual results. The y-axis here shows the number of reported crashes based on the City of Lafayette's police databases. You can see here 2012 shows about 36 crashes per year, and then a little bit more in 13, a little down in 14, and kind of has this consistent pattern of around 36 crashes per year. This is actual crash reports the City of Lafayette Police Department receives when a crash occurs and one of the parties involved calls for police assistance. So if you dig deeper into those reports, which we did for year 2017, the most recent crash year, you can see that there is the frequency in which they occur is about one crash every 10 days in the corridor. So those 38 crashes that occurred in 2017, 5 of them involved someone who was walking, 1 of them involved someone who was riding a bicycle, and then 5 of them involved a crash with an RTD bus. All of the other crashes were strictly car-on-car crashes. So these numbers that you see here were an instance where either someone was walking was involved in it, someone was riding a bicycle involved, or an RTD bus was involved. If it didn't involve any of those, then it was just a car-on-car crash. Of those 38 crashes in 2017, 10 of them involved an injury where there was either medical assistance called or someone noted the need for some help as a result of an injury. So those were 10 of the crashes. And then the most common occurrence, if you can find one in this data set, because it's kind of doesn't have a systematic pattern, but when you do pull out some of the frequency types which occur, it's broadside and rear ends. So broadsides are side instances where the vehicle gets hit on the side, and then rear end is in the trunk or the front end of another vehicle, so a rear end situation. Based on the 38 crashes that occurred, there's no distinct pattern or corrective measure. And what that means is that if you look at all the crashes, there wasn't one particular intersection that had all of the crashes or even a pattern of crashes. It was also not one specific type that kept occurring over and over. And then if you look at those both together, there wasn't a pattern at a particular intersection with a particular crash type that actually suggests that there would be one way to mitigate it. So that's a summary of the crash data that was compiled in the corridor for 2017. So in addition to the crash data, we also looked at stop sign compliance at intersections that have stop signs today. So the first one we looked at is Canon, and this study was done with using video equipment. And this data set you see here is a sample of, it's a sample of the entire day, but it's the results from the morning peak hour, which we looked at 7:45 a.m. to 9 o'clock a.m. And the green, the 35% here, is when someone actually driving a vehicle made a full stop at the stop bar. And that means when that person approached the stop bar, they stopped in advance of the stop bar, and the wheels actually stopped moving. So you could stop and read the entire logo, as an example, on the center cap of the wheel. That's a full stop. And so 35% of the stops were full stop. The 62%, that big yellow percentage, was that they rolled over the stop bar and they did eventually stop. And in this case, the stop was that it was what some may consider kind of a rolling stop. So they did stop eventually, and that stop was not a full wheels, totally locked up stop. This type of stop is very common, and the stop is consistent with people who maybe see someone else and could make a panic movement and get that full stop to occur. So unlike the 35% where the wheel fully stopped, the 62% is an instance where they roll stopped, but they did have what we would consider a stop. The 3% is a roll stop, and they never stopped at the bar. So in this case, they never actually made a stop at the bar, and they rolled through it without having a slowing movement. So the wheel consistently moved, and it's a roll stop. So in this instance, if someone had to make a panic stop because they saw something else going on, it would be a little bit harder to make that panic stop. And then from the 7:45 to 9 o'clock morning hour, we didn't see any instances of people rolling through entirely the stop sign without making some form of braking movement. And so we consider that a no stop. And so we didn't see any of those in the morning period. So this is at the Cannon intersection. I'm going to show you the results now of the PM peak period. So once again, you can see the green, the full stop at the stop bar at 21%. And then that yellow, that roll stop at the bar. And then the 3% of the no stop at the bar. And so that's an example here of how the data shows between the morning and then the afternoon. So I'll just do that once again for you here. So here's the morning. So we have 35% full stop, and then it goes down in the PM to that 21% full stop. What's noticeable is that most of the vehicles, so if you say over half of the vehicles in both situations, are making some movement that's trying to comply with the stop bar. And so you see 62% of them here and 76 here. And then we looked at what happens when there are pedestrians present at the crosswalk. And so when someone walks up to the crosswalk from a side street or the main street, do vehicles actually yield? And in this case, when we looked at 40 observations in the morning peak hour and the evening peak hour, we saw that 88% of the time a vehicle does yield to the pedestrian at the stop sign when they approach. And so they wait for that pedestrian. They arrive, they see somebody who wants to cross, they stop and they wait and they let the person cross. 13% of the time, which is this red wedge here, a vehicle approached the stop sign and they stopped in some format based on the prior data, and then they continued on without waiting for the person who was waiting at the side.